counter, what will be the output of the counter? So that will depend on what is the input. Okay, for example, you are taking JK flip flop. So what are the JK input? But only JK inputs will not decide what will be the next output. Okay, next state. So that depends on what was the previous state of that particular circuit. Okay, that means what was the history. So that also matters in the sequential logic devices. Okay, now uh, going ahead of this, these are the sequential logic devices which are programmable, which are programmable. So what is programmable? Why, which things you can call as programmable? Any answer to this? If something is programmable, okay, for example, I call that my let us say my some device, okay, washing machine. My washing machine is programmable. My washing machine is programmable means what? I can set a program for the washing machine. Or my oven is programmable, so I can set a program, I can give a program to my oven. So what do you understand by this? Anyone? Some device is programmable means what?
Means, sir, it has some kind of digital circuit or a digital input which works on command.
Which work from the command. Yes, that means I can give command. Okay, so I can write a program, isn't it? I will write sequence of commands, and now that device will function according to those particular commands. Getting? So that particular device is capable of doing the things in variety of manners, but in what actual fashion that particular device should work. So I am going to give instructions in the form of program. So group of instruction is nothing but program. Getting? What is your computer? Computer is a programmable device, isn't it? So what are you doing for the computer? Compute for a computer, you are writing, you are giving a group of instructions, and that group of instruction is nothing but your program. And what your computer does, your computer works according to what instructions you have written in your program. So when actually you are executing your program, then what happens? Your computer works according to that. Okay, now what are these programmable devices? For example, the first one is SPLD. Okay, that is simple programmable logic devices. Simple programmable logic devices. Okay, that means these are the uh, PLDs. Okay, simply they are called PLD, that is programmable logic devices. Programmable logic devices in the sense that these devices are programmable, means you can program these particular devices for a particular function. Usually what we do, we connect the AND gate, OR gate together to form a multiplexer to the adder. Again, we connect multiplexer, adder together to have some devices like ALU and like that. Okay. So what are we doing is that we are hardwiring, we are connecting, we are giving the output of one device or one logic gate to the other logic gate and like that. And then we are deciding what will be, or we are going to design a particular circuit. For example, we are designing counters, we are designing shift register, we are designing adders, we are designing multiplexer, we are designing decoders, encoders, like that. Okay, so in this, what are we doing? We are giving the output of one gate to the other gate. Okay, so as all of you know that any digital electronic device can be built out of the basic building blocks, that are the logic gates. The basic gates, they are the AND gate, OR gate, and NOT gate, whereas there are some gate like NAND gate, exclusive OR gate, and which are uh, the composite gates formed from the AND gate, OR gate, and NOT gate. So we may use those particular gates. I think I will take 1 minute break so that few students who are waiting, I will be able to get in. Only one was there was a alert. Only one was waiting. Okay, no other. Okay, so coming back. Uh, so is the screen visible again? SPLD, CPLD, and FPGA. Huh?
Yes, sir.
Okay.
Yes, sir.
So these are the programmable. These are the types of programmable logic devices. That is SPLD, CPLD, simple programmable logic devices, CPLD, complex programmable logic devices, and FPGA, that is field programmable gate array. So these devices, the programmable logic devices, are in the sense that the manufacturers are not going to manufacturers are coming out with this particular devices, and they are not setting a specific function for these particular devices. Okay, so these devices, the function of this particular device is programmable. That means you will be having a device. You can call that particular device a single chip as the PLD. Okay, if it is a small, then it will be called SPLD. If it is a large, then it will be called a CPLD, or even if it is larger than that, then FPGA, that is field programmable gate array. So this particular device, logic device, okay, is programmable in the sense that you can program it. Okay, so it is a single IC. Okay, it is a single IC, and which is programmable. Programmable means what? You can decide, you can configure that particular chip such that the chip will function as per your requirement. Okay, for example, if you take SPLD, a small programmable logic device, then if you want that particular chip to work as adder, then you program the chip such that it will work as adder. Okay, if you want that particular chip to work as multiplexer, then you program that particular chip such that it will work as multiplexer. Okay, so these are very small adder, multiplexer, it is very small things to program, but you will be able to have the logic functions which are more complex than simple adders, encoders, decoders, multiplexers, and like that. Okay, so you will be able to write a program, and in that particular program, you will be specifying what is your digital circuit. It may be a combination logic circuit, or it may be a combination logic circuit, or it may be a sequential logic circuit. Okay, so in the PLD, you can construct your resistors, you can construct your counters out of this particular PLD, that is programmable logic devices. Or CPLD, in the CPLD, again large amount of such devices, configurable devices will be available, and out of that you will be able to construct whatever digital circuit you want to construct. That means you don't need to hardwire manually by using the soldering gun and on some board put the OR gates, the OR gate IC, AND gate IC, NAND gate IC, and like that. Or even you may be aware that the ICs are available for the multiplexers, adders, and all that. Okay, but even if we are going to form or design a circuit out of multiplexers, adders, and all that, so we need to integrate. We need to put all these particular ICs, integrated circuit, on a board, and that particular board is called printed circuit board. The short form is PCB. So there is no need to do this. What we need to do is just get this PLD devices and program it. Okay, so inside it, complex circuitry is there, which is configurable, which is programmable, and out of that you can get the required functionality done. Okay, so these are the features of the sequential logic devices. Sequential programming devices include both gates and flip-flops. So, large number of gates and flip-flops are there inside this particular devices. The device can be programmed to perform a variety of sequential circuit functions. Okay, of course, in that combinational functions also will be there, but most of the time, the sequential circuit functions they are important because sequence of operations are to be performed in any operation. There are several types of sequential programmable devices available commercially. So these three major types are SPLD, sequential programmable logic devices, but many times this is also called simple programmable logic devices. Okay, then CPLD, that is complex programmable logic devices. FPGA, that is field programmable gate array. So three major types of devices are there. Then the this is the SPLD, the sequential PLD is sometimes referred as simple PLD to differentiate it from the complex PLD. The SPLD includes flip-flops in addition to and or array, which is integrated circuit chip. Okay, so this is the general simplest way of specifying SPLD. So there is a and or array. The array, this particular array is of type PAL, that is programmable array logic or programmable logic array. So these arrays, which are the is essentially the combination logic circuit, and it is followed by the flip flop. Okay, so this is how one may go for constructing or these particular SPLDs are constructed. Okay, so they are note that all these they are in a single device, that is single IC. Whereas this particular array is programmable. The PAL is a programmable array logic. So you can program it so that the functionality of this particular circuit can be decided. Okay. Then the PAL or PLA is modified by including a number of flip-flops connected to form a resistor. The circuit output can be taken from OR gates or from the output of the flip-flop. Okay, so PAL or PLA is something which is programmable. That means which is configurable. So that this particular point you should note. Okay, the uh, I think this is the same slide which is repeated. The circuit output can be taken from OR gate or from the output of the flip flops. Okay, then each section. Okay, so this is how the programmable array would look like. Okay, each section of an SPLD is called a macro cell. Okay, so this is the macro cell, how it looks like. Okay, so there are AND gates followed by the OR gate, and this circuit that contains the sum of product or combination logic circuit and the optional flip flops. Okay, so you can see here that there is array. There are cross lines, that is vertical lines and the horizontal line. So what is programmable? The connection of the cross point, whether there should be a connection at the cross point or there is no connection at the cross point. So that is programmable. Okay. So by making that connection, by making a connection here or by disconnecting those particular cross point, you can achieve various functions. Okay, so there are inputs to this particular circuit, this particular micro cell you can say, and there are outputs, and by making these connections at the cross points, we achieve the different types of the functionality for this particular micro cell. So this is one micro cell. So like that, there are many micro cells in the SPLD. At the end of this particular microcell, there is a flip-flop, which is a D flip-flop. Okay, so this is how it is constructed. The output is driven by an age trigger D flip flop connected to a common clock, and the input changes state on a clock age. Okay, so this particular flip flop will change its in change as per the input at the positive age of the clock. That you are aware that clock input is required for modifying the state of any flip flop. The output of the flip flop is connected to a three state buffer. Okay, on the right side, top right side, you can see that particular three state. It is a three state buffer. Okay, or it can be inverter controlled by an output enable signal marked in the diagram as OE. Okay, so that particular output enable, if it is enabled, then only the output of that particular buffer it will be available. Okay, or that particular three state buffer will be available. Okay, then the output of the flip flop is fed back into one of the inputs of the programmable AND gate to provide the present state condition for the sequential circuit. Okay, a typical SPLD has 8 to 10 micro cells. So whatever you are able to see only one cell. So in a typical SPLD, there are 8 to 10 such micro cell which are packed inside a single IC package. IC is nothing but the integrated circuit. Okay, all the flip flops are connected to a common clock input, and all three buffers are controlled by OE, that is output enable input. Okay, so having seen the CPLD, now you can see here the configuration or the how the CPLD look like. Okay, so CPLD is some complex version of you can say SPLD. The figure you are going to see. I hope the slides they are moving and you are able to see those particular slide. Quick reply. You are watching the CPLD slide now.
Yes, sir.
Mhm. Okay. So yes, thank you. So figure this particular figure shows the CPLD, that is complex programmable logic devices. The device consists of multiple PLDs, that is multiple programmable logic devices interconnected through a programmable switch matrix. Okay, so there is a programmable switch matrix at the center. You can see that it is a programmable switch matrix. So again, this particular programmable switch matrix, it is nothing but the cross lines, vertical lines and horizontal lines. So there you will be able to make either some connection or there will be no connection. So what is programmable in all these devices? In all these devices, programmable logic devices, making of some connection or no connection. So based on that, if you make some connection, the functionality will be something. If you break some connection or if you do not make that connection, the functionality will be something different. Okay, so it is not only one connection, but there are large number of such connections at every cross point, and because of that the functionality of the devices will change. Okay, then in this you can see that there are IO blocks. Okay, at the left corner and the on the right part there are IO blocks. So this particular IO block, they are nothing but the input and output blocks which are provided for the connection to the IC. Okay, so you can see here that in addition to the PLDs, okay, so this particular PLDs, they are similar to SPLDs. Okay, so that means number of SPLDs they are connected together, and again there will be interconnection between this particular SPLDs or PLDs by using this particular programmable switch matrix. Okay, so if you are going for a design of a complex digital circuit, then in that case it will be able to possible this to configure that particular circuit. Okay, that means you will be using first SPLD to to configure one part of your circuit. You will be dividing your circuit into the different parts, and each of the PLD will be you will be able to configure some part of your circuit, and then again there will be connection between the different part of your circuit, and that particular connections will be achieved by using this particular central part, that is the programmable switch matrix. Okay, so one part will be achieved with the help of this particular one PLD. So like that, the different part will be achieved by using this particular PLDs. Okay, so like this, you will be able to achieve this particular, or you will be able to uh, program this particular CPLD. Okay, so each features of this CPLD, each IO pin is driven by three-state buffer, can be programmed to act either as input or output. So this particular IC will be having the pins which you can program either for the input or output. The switch matrix receives input from IO block and directs them to the individual microcells. Uh, the microcells, as you are aware, they are the part of the PLDs. Similarly, from uh, selected outputs from microcell are sent to the outputs as needed. Okay, so the outputs again, they are in the IO blocks, and the outputs will be again made available in the IO blocks. Okay, so inputs and outputs will be done from this particular IO blocks, and connections of that, they are taken out uh, at the uh, output pins, or the at the pins of the CPLD, which will function either as input or output. Each PLD typically contains 8 to 16 micro cells. Okay, that means essentially every PLD is something like SPLD, usually fully connected. If microcell has used product terms, they can be used by uh, other nearby microcells. In some cases, microcell flip-flop is programmed to act as D, JK, or T flip-flops. Okay, so the flip-flops which are there in the microcells, they are programmed such that they can act either as a D flip-flop, or they can act as a JK flip-flop, or T flip-flop. So depending on what functionality is required, you can make those particular flip-flop to act appropriately. Okay, then the next feature of the okay, so those are the features of the CPLD, and the last part of this is FPGA. Okay, so please wait for some time so that we shall finish this FPGA. So you may be getting late for 5 minutes for the next lecture, but please wait. FPGA is a field programmable gate array. So this field programmable gate array is a VLSI circuit. VLSI in the sense very large scale integration circuit. That means there are many devices inside this particular inside this FPGA. Okay, that means it is even complex than CPLD. FPGA is even complex than CPLD. Okay, then a typical FPGA consists of an array of millions of logic blocks surrounded by programmable input and output blocks and connected together via programmable interconnection. So large number of blocks are there inside this. There is a wide variety of internal configuration within this particular group of devices. The performance of each type of device is it depends on the circuit contained in its logic blocks and the efficiency of its programmed interconnections. Okay, as far as these three devices are concerned, SPLD, CPLD, and FPGA. So what is important is that you should know the block diagram of all these devices, and you should know features of this particular devices. So all this particular topics, they are theoretical. So what is important is that knowing the features and knowing the block diagram of each of this part. Okay. The features of FPGA, continuing the features of FPGA, a typical FPGA logic block consists of lookup tables, multiplexer, gates, and flip-flops. A lookup table is a truth table stored in an SRAM, that is static RAM, and provides the combinational circuit functions for the logic block. Okay, the advantage of using RAM instead of ROM to store the truth table is that the table can be programmed by writing into memory. Okay, so the disadvantage is that the memory is volatile and presents the need for the lookup tables content to be reloaded in the event that the power is disrupted. Okay, so one major thing in the FPGA, the difference between FPGA and the PLDs, okay, is that they use FPGA use RAM, that is random access memory, and all of you know that what is the major difference between the RAM and ROM. ROM is non-volatile. Even if power goes off, the contents are stored in the ROM. But in case of RAM, the power is not the power. Sorry, the bits they are not stored, so it is volatile. If power goes off, the contents they are lost. Okay, so when FPGA device, if you disconnect power to the FPGA device, then the contents of the RAM are going to decide what is its functionality. So if that functionality has gone, then it has to be reloaded. The functionality is to be reloaded in the RAM. So from where it will be reloaded? It can be reloaded from the lookup table, or in the other way, you can say that you can change again and again. You can change the functionality of FPGA. Okay, so just by loading the different data inside the RAM of FPGA, you can change the functionality of FPGA. So that is the difference between FPGA and PLDs. Whereas in the PLDs, once you have stored something in the ROM, that is, you have made some connection, or you have made some disconnection. So in that case, the functionality of that particular device is final. You cannot, after that, you cannot change the functionality of the PLDs, okay, or SPLDs or CPLDs. But in case of FPGA, you can reload the functionality. That is, when you reload the RAM inside FPGA, the functionality will be changed. So that is the major difference between FPGA and CPLD. Of course, the FPGA, they are larger than CPLD. Okay. Now you can see here that as expected, this particular FPGA is more complex than CPLD. Okay. So what it uses, the building blocks of this particular FPGA, they are the CLBs, that is configurable logic blocks. Okay. Then for the purpose of outputting, they are the IOBs, that is input output blocks. Okay, and of course there are programmable IO buffers, and SRAM, that is the static RAM is there. Okay, so all these, they are based on this particular switch matrices. Yeah, you are able to see all these particular switch matrices. So all these, they are sorry, the slide has moved. Let me locate. Okay, so this particular switches, they are SRAM based. SRAM is static RAM based uh, configuration memory. Okay, so in case of static RAM, again, there are provisions that even if power goes off, the contents will be still there. Okay, so this was the block diagram of the FPGA. Okay, so we have seen the features of FPGA also, and the block diagram of FPGA, what it contains, that is CLB, switch matrix, and IOB. Okay, if required, you can in the book you can go for how is the internal block diagram of CLB, that is configurable logic blocks. Okay, so it is available in the book of Morris Mano. Okay, so this is the summary of what we have seen today. So have you understood, got the idea of what is the PLDs, programmable logic devices, that is SPLD, CPLD, and SPLD, CPLD, and FPGA. Yes, quick response. Understood? Hello, hello, student. Are
Yes,
you?
sir.
Huh?
Yes, sir.
How many?
Yes,
How
sir.
many
Yes, sir.
student? How many students are there in the session?
Yes,
47.
sir.
Okay, 47. Good, good. Okay. Now, what is our third unit? It is VHDL programming. What is the third unit? VHDL programming. Okay. Now, in this topic, we have seen that we can configure. Okay, we can, as per our wish, that particular circuit will function either as a counter, either as a shift register, either as a adder, either as a multiplexer. Okay, so it is configure means it is programmable. That means we should write a program. So in the program, we shall giving the instructions, and as per that instruction, the program, that particular circuit will work. Okay, so VHDL programming is nothing but in the we shall be writing a program. Okay, so the third unit is very easy, you can say. Okay, because already you have studied C language, and of course this particular syntax of this particular VHDL is not exactly same as that of the C language, but because you have already studied C language, uh, it will be easy for you to learn this particular VHDL language. In the third unit, you are going to learn that VHDL programming. Okay, and you will be going through the simple programs, and later on somewhat complex program with which you will be able to configure. So this particular programs will be used to configure the either SPLD or CPLD or this FPGA. Okay, so we shall stop here, and we shall meet in the next class. Okay, so tomorrow there will be lecture instead of test. We shall schedule the test at some other time. Okay, bye and good day to all of you. I hope all of you have marked the attendance. So it is now already you are late for the next class. Join the next class. Thank you.
Thank you, sir.
Okay, thank you. Which is the next class?
Sir, OOP test is there.
Sir.
Okay, OAP test was there, no?
Yes, sir.
Okay, if whether the time will be sufficient to you, remaining time.
Mm, Sir, don't know about